Welcome back. Today we're going to be looking at transformation of functions. This is adding, subtracting, multiplying, dividing, and then composing, which is the newest one. And that'll maybe be the hardest part of the whole day. Everything else should be pretty review and pretty easy. Today we're going to look at a couple different ways to do things. So it's really important that as we go through them, you think about how you could apply this to not only numbers, not only the functions we're doing, but to any function in the world, not just the one function we're working with. All right, let's get started. We'll see how quickly we can master this. So, say the creed, say it out loud, say it loud and proud. It's going to help you pass the class. And if it doesn't, then you can blame me. Today's a new day. I can read and remember well. I can develop my viewpoint and apply it correctly. I have eyes to see, ears to hear, and a mind to understand. It might not be easy, but it's worth it. All right, let's get started. So the first thing we're going to look at is the basic operations, right? If you have two numbers, you can add them, you can subtract them, you can divide them, you can multiply them. Well, here, if you zoom in and we look at this, if you have two functions, all that a function does is funnel a number x, right? Some number x, funnel it through a system of operations and give you a return number or an output y. So we can add those y's, we can divide those y's, we can multiply those y's. We can do anything with that output, right? And that's kind of what this is saying. And then the note on the domain is important to notice that the domain for each of these is just the intersection or the Venn diagram section, if you think about a Venn diagram, where the two domains are in common, which kind of makes a lot of sense. The only hiccup is this little hiccup right here where it says, hey, if we're dividing two numbers, the bottom number or the bottom function better never be 0. And we'll see how that comes into play. All right, so let's get started. Shouldn't be too crazy. Let f be this function. Remember, that's called a rational because there's an x on the bottom. Just a review. And let g be this function. That's the square root function, which is the top half of a inverted or an inverse parabola. So let's see. Determine f plus g of x. That's a way to read that if you want to read it. F plus g of x. So f plus g of x. It's kind of like saying if we use that formula from above, I'll go up real quick, right here, underlined in green. If we use that formula, it's the exact same thing as f of x plus g of x. Okay, well, we have f of x and g of x uniquely, right? So we have 1 over x minus 2 plus the square root of x. Guess what? We're done. It's that easy. That is f of x plus g of x. Now, might they do little operations to change it? Absolutely. But that's as simple as it gets because they're not like terms, so we can't combine them. Because remember, like terms have to have the same variable. Oh, well, those have the same variable x and the same exponent. And technically, our x on the right has an exponent of 1/2, and our x on the left has an exponent of -1. So those are not the same exponents, so they're not like terms. We can't combine them. And then, when you see this normal function notation with the number inside of it, right here we've got a highlighted 4. All we're going to do is plug that 4 into our equation, right? So watch this. So f plus g, f plus g of 4 equals, using that last equation we just invented, 1 over 4 minus 2 plus the square root of 4, which is going to be 1 over 2 plus 2, which is going to be 5 over 2. If you're okay with that? So it looks like that. Awesome. Subtraction, multiplication, division, all the same thing. It all works the exact same way. You can look at these notes to kind of help out with what you're going to end up getting. I'll go ahead and do this subtraction real quick. You're just subtracting two functions. We're rewriting the exact same functions except a minus sign in the middle, right? And there's our function. And if we wanted to plug 4 in, we'd probably end up in the same boat as before, right? You can look at these notes. I have them all filled out nice and neat. Exact same thing. All the thing we're switching is that minus sign in the middle. So that's going to be 1/2 minus 2, which is probably going to be -3/2, I believe. Because minus 4 over 2, yep. Okay? Not too crazy? Not too wild? All right. Let's multiply some numbers, see what happens. So we've got the same exact thing where all we're going to do is break apart our function and go f of x times g of x equals, we've got 1 over x minus 2. I'm going to put parentheses around them just so I can keep my numbers straight. Boom. That's our function. Fantastic. And plug in 4, see what happens. So we'll get 1 over 4 minus 2 times the square root of 4, which would be 1 over 2 times the square root of 4, which would be 2 over 2, which is 1. Okay? Now you'll notice what I'm not doing right now. I'm not checking my domains because the question that didn't say define the domain, but I think it's worthwhile, and we'll go back and do all 4 at once to look and see what can this domain be and what can't it be. So if you were thinking that in your brain, like, what about that domain part? We're going to do that all at once. Last but not least, f divided by g of x. So that's f of x. Oh, I'll write it out. That's f over g of x is the same thing as f of x over g of x, right? So now we've got 1 over x minus 2 all over, it's important to make that line bigger than the first division so you know what's happening, all over the square root of x. And if you think back to keep, change, flip, keep is the green, so I'll keep that green, 1 over x minus 2. Change is the multiplication to division, so I'm going to change that division sign to multiplication, that's the blue part, and flip the bottom. If that's a fraction, technically that's a fraction over 1, so I'm going to flip it to 1 over the number. That's the keep, change, flip review. It's a quick review. If you want more review, come to office hours, we'll work on keep, change, flip. So we end up with 1 over x minus 2 times the square root of x. And if we plug some numbers into that, we should get, what are we plugging in? Sorry, I jumped the gun. That's the function. If we plug 4 into that, we should get 1 over 2 times the square root of 2. And that's, oh, no, the square root of 4, which is 2. So 1 over 2 times 2 is 1/4. Not too bad. Okay. This is a side note. There weren't a lot of questions to give you in the review or anything, but it's just like a little side note about you can interpret addition and subtraction visually. So visual addition and subtraction is kind of interesting. So if these are just y numbers, right? We're getting output y values. A function is taking an x and turning it into a y. So right here, what we're being output is this y value, right? And right here, what we're being output is this y value, right? So couldn't we add those two y values? So let's see. If I take this red y value, oop, that's the blue one. Hang on, let's get this out of here. Whoa, that doesn't work. Hang on 1 second. All right, I'm going to copy this real quick. If I take this red y value and I move it over here, and then I build a blue y value like this, right? And the same x. And then what I'm going to do is I'm just going to add them to each other right here. Like, boop. Guess what I've got? I've got a new y number that was the blue y value plus the red y value, right? And if I do that a billion times, like a billion trillion times, I should get a function above the line at all points, right? So let's see if that happens. Yeah, let's just check it out and see what happens if we do that. So if we add these two numbers, we probably get that same point, which is kind of wild. And if we add this number, let's copy it, duplicate, move it over here. Whoops. Duplicate, move it over here, draw a blue line, getting us up to the blue. Then move it back over right on top. Boop, there's another point, right? And if I were to just do that a million times, I'd probably end up with a function that looks like that, right? Maybe it looks a little different than that. I don't know for sure. It'd probably look a little bit like that. We'd have to do it a bunch of times to see, but that's what kind of graphical addition is. And I think it's pretty cool. It's just another way to look at it. Cool? Awesome. All right. Let's see. All right, so here we go. This is the main part. This is the main thing of this whole video is composition of functions. So if we can add functions and we can subtract and divide and all that stuff, functions allow us to do a new thing, which is take a number and plug it into a function to get another number. Well, couldn't we take a function and plug it into a function to get another function? So what this looks like is this little of, that thing stands for the word of, f of g, or f composed with g. So f of g of x takes x, funnels it through g, gives you some number, and then funnels it through x, f, and gives you some other number. So let's see, let's find out. So f of g of x is equal to f of, and then let's just plug in g of x, x minus 3. And then what we're going to do is everywhere we see an x, we're going to plug in that thing. So in f, we see an x right there, only one of them, right? So we're going to plug in x minus 3 squared. And there we go. We got f of g of x. Not too crazy. What about g of f? G of f of x equals g of x squared equals x squared minus 3. And we just plugged in one at a time up the chain. And then we could plug a number in, check it out, and see what happens. So red function, if we plug in 5, we get 5 minus 3 squared. 5 minus 3 squared is something like 2 squared is something like 4. And for blue function, g of f of x, we get 7 squared minus 3, 49 minus 3, 46, something like that. Okay, working our way through slowly. Determine the domain. Ooh, here we go. This is the first domain question. Oh, that makes me realize that I forgot to go back up and do the domain. Let's do that after this. So the domain of f of g of x. We have to do two things. We have to find the domain. I'm just going to write domain of the inside. Let's do that first. Domain of the inside. So what's the inside? It's f of g of x. So the inside is g of x, right? So what's the domain of g of x is the question. Well, I'm going to go back up and look at g of x. X minus 3. Are there any bad numbers? Anything x can't be? No. That's a normal line that goes on forever to the left and on forever to the right. Just shifted down 3. So the domain for g of x is all real numbers, right? And then you have to do the domain not of the outside function, but of the outside function with the inside function inside of it. So that would be the domain of f of g of x. F of g of x. So f of g of x is that red function up there, which is just x minus 3 squared. Is there any number that x can't be? Is there a square root that we can't have a negative? No. Is there a division that we can't have a 0 on the bottom? No. So I don't see any bad numbers right now that we can't have, that are illegal numbers to have. So it looks like another all real numbers. And then we intersect those two things. We say, what's the intersection of a set of all real numbers and a set of all real numbers? What do they have in common? All real numbers. And then I can let you do the second one or check the notes and see if you can figure out the second one on your own. All right? That's composition of functions. You can also compose 3 functions if you want to. Composing 3 functions isn't that crazy. It's literally just taking it and doing it 3 times. So I like to write it like this. F of g of h of x. That's how you rewrite that. And I like to do it one at a time in color. So h of x is red. So I'm going to take it and plug it in for this red one, right? So now I'm left with f of, I'll write it a little smaller, f of g of, what was the red function? X plus 3. All right. Now we got to do the blue function, right? G. Here's my blue function, x to the 10. So what I'm going to do is every time I see an x, I'm going to plug in my red function into that function, right? So that gives us f of, because we're not touching that one yet, and now we're writing x to the 10. But instead of that x, what do we have? We have all this mess, that red function, right? Okay, so there's where the blue thing kicked in. And now we'll do this green function. The f is the green function, right? So anytime we see an x, what are we going to plug in? What we just got. So every x is going to get that thing. So here we go. Equals x over x plus 1. But instead of x's, what are we writing? That whole function from the other side. X plus 3 to the 10. No x. It's actually x plus 3 to the 10. And that is our function. Okay? And you can see where each part, the f and the g and the h, all helped contribute something to the function. The inside function did the innermost thing, which is that x plus 3. The next function did the blue thing, which is this raised to the 10. And then the outside function did the very last thing, which is that giant divide sign and the 1 on the bottom. Okay? Not too bad? All right, then there's one cool application, and that's it for today. So here's it's just like a fun application, like, hey, when would we ever use this? Here's an option. So you got a lighthouse, right? I think that's what it says. Ship is traveling 20 miles per hour. So I'm going to write 20 miles per hour parallel to a shore. So I'm not going to draw that lighthouse. I'm going to draw a shore. Here we go. There's a shore. There's a ship. And it's going parallel. Parallel means like never touches, right? So it's going 20 miles per hour that way. The ship is 5 miles from the shore, right? Boop. So here's the question. Is that blue line, is that 5 miles ever going to change if it's going parallel? It's going to stay 5 miles forever. Just a thought for our brain. It passes a lighthouse at noon. Here's my lighthouse. So let's pretend the ship's at noon right now, right? Okay. Express the distance S between the lighthouse and the ship. Ooh, so that means that ship's moving, right? So what that means is if that ship is moving at some point later down the road, it's going to be down here, right? Okay. So it's saying express that distance, a distance S, call that S, between the lighthouse and the ship as a function of D. So our function would be S of D, where we usually have f of x, a function of x. We plug in an x into some system. Now we're plugging in a distance into some system to give us another distance. Since noon. So what is S of D? Oh, that just looks like the Pythagorean theorem, doesn't it? I think so. Let's see. The distance between the lighthouse and the ship is a function of D. The distance the ship has traveled since noon. So that D would be this distance this way. Right? Okay. So we've got the Pythagorean theorem. Just on a side note down here, Pythagorean theorem is a squared plus b squared equals c squared, right? And where c squared is the longer side, so c is going to be s. And a and b can be interchanged, so we got 5 and d. So we've got some function, and if we square root both sides, we're going to end up with the square root of 5 squared, which I'm going to go ahead and write 25. 25 plus d squared. So that function tells us the distance the ship is from the lighthouse given some time, or no, some distance past traveling. But I bet it wants time, and that's what we're going to end up finding. So now it says express d as a function of time. Express d, the distance is traveled, as a function of time. So that would mean d, it says find g such that d equals g of t. Cool? Okay? So the distance traveled is going to be some g of t, right? Some function of time that gives us a distance output. So we know he's traveling 20 miles an hour. So if he's traveling 20 miles an hour, and then we multiply the time he travels, that's like saying, hey, I'm traveling 20 miles an hour down the road. Give me an hour, how far will I be? 20 miles. Give me 2 hours, how far will I be? 40 miles, right? And so there's our function. That was actually not too bad. I'll show you a trick to check in a second once we're done. And now surely we're just composing. There you go. Find f of g of t. So f of g, that's how we say that, of t equals f of g of t. I always rewrite it with those brackets so I can see. And then I'm going to plug in my g of t, so f of 20t. And then I'm going to plug that into my original function, f of x. Ooh, I wrote s of d, and right here it says s equals f of d. So I'll just go ahead and rewrite that as f of d as well. Same thing, same exact function, just so we're using their notation. Okay? So f of that would be the square root of 25 plus, and now anywhere I see a d, I'm plugging in that last function, 20t squared. There we go. If you want to simplify it, you're welcome to. You're welcome to say, what is it? Let's see, that would be, what do we find total? S equals the square root of 25 plus 400 t squared, right? So that's saying, what does this function represent? Well, what did S stand for at the very beginning? S stood for distance from lighthouse, right? I'll write that down. And what did T stand for? T stands for time traveling, right? Time traveling. So this function gave us a distance from the lighthouse based on the time that he's traveled. And we had to do 2 steps to get there. The first step was Pythagorean theorem. The second step was incorporating time and composing those 2 functions. So there's a practical application of it. I think it's kind of cool. Yeah, so if you're interested in more of those, you can look through the book. There's 4 or 5 different practical applications of composing functions. Look through the completed notes, look through the book, look through the textbook, look through any other resources you have to try to master this composition of function, because it's going to keep coming up over and over again. So it's really important lesson to try to master. All right, thanks for watching. I'll see you soon. See you in class. Make sure you're taking care of all the stuff you need to, whether it be homework, suggested homework, quizzes, everything you got that you can be working on. Sweet. See you soon.